Alright class, so this is my video for ring closing metathesis, and I'm going to show you the mechanism behind this reaction as well. And really the hardest part of a problem like this or writing out a mechanism like this is keeping your number of carbons straight and making sure that your pictures look nice. So when I was preparing to make this video, I went through 2 or 3 iterations of writing out sort of the notes to make the video because my pictures did not look good, or because the way that things were lining up was not satisfactory. So when you're doing these problems, when you're getting started in inorganic chemistry, feel free to make mistakes. It's okay. And I think starting over, so throwing the piece of paper away and starting over, that's something that will, your pictures will start to look better, your paper will start to be more clear, and that will really help you remember, right? Make those neural connections in your brain to remember this sort of stuff. So let's get started. When I look at a problem like this, sort of the things I'm looking at, I've got double bonds, I've got olefins, and I've got my olefin metathesis catalyst. So this is really the only sort of thing that this metal double bond to carbon, I've got hydrogen in some R group. That's really the only thing that this species is going to do. So whenever we see this, we should be thinking olefin metathesis. If you're just given a big sort of ring type thing, you can rest assured that we're going to be talking about ring closing metathesis as opposed to just a simple olefin metathesis. So metathesis again is just a fancy word for exchange. And I know from my experience that essentially what's going to happen is I'm going to do an exchange between these two olefins, and really I'm just going to sort of click those together. And my end product, or products really, is going to be this cyclohexene and something that looks like this. So this could really either be, we could think of this as ethylene. I could have a hydrogen here. Or this could be an R group, and that R group is going to come from this metal catalyst. So really whatever way we show this other product is really okay. This cycloalkene here, that's really what we're focused on, I would say. So let's work through this and prove to ourselves that these are going to be our products. And when we do this, when we show the mechanism, it's really just always a good idea to line up our species really nicely. So here is my metal catalyst, and then I'm going to draw this species here. I'm going to draw things a little bit bigger, trying to make it as clear as possible. So let's just, again, double check the number of carbons we have. In this ring, I've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 carbons. So we're in good shape so far. This reaction mechanism is going to look like this, where we're sort of doing that, that double bond dance, essentially, that olefin metathesis. So our intermediate, we're going to have this 4-membered ring sort of box, if you guys remember that from earlier. So again, 1, 2, 3, 4, 5, 6, 7, 8. So just make sure you're counting your carbons. You've got all of them accounted for. If this becomes sort of hard to follow where your points are, feel free to draw in some little dots there. I think that's a nice way to keep track of your different carbons. So again, we've still got our 8 carbons. We're going to continue our little shuffle dance, essentially. Let's put our hydrogens on here so we're just consistent and clear. So then from here, let's go ahead and just move this up. We're going to get our metal, and then we're going to have a new double bond here so now this carbon is going to be right here. And now we've only got 1, 2, 3, 4, 5, 6. So counting from here, so from this, let's call this 1. So 1, 2, 3, 4, 5, 6, 7. So 1. Trying to draw this as best I can. 2, 3, 4, 5, 6, 7. That's going to be where we have our double bond. And then our other product is going to be CHR. So I've got this R from my metal catalyst, double bonded to CH2. So this is sort of the first sort of byproduct of this reaction, and now we've got this new sort of, species to deal with. And now from here, we're going to again want to sort of redraw that so that things are all lined up nice and neatly. So the way that we can do that is if I redraw this picture like this. So let's again double check to make sure that we've got all of our carbons accounted for. Over here we've got 1, 2, 3, 4, 5, 6, 7. So this would be number 1, 1, 2, 3, 4, 5, 6, 7. And I've drawn it this way to again line up those two olefins so that I can again do this metathesis process. So I'm going to write in a carbon there and put in the hydrogens just for clarity's sake. And we're going to start moving these electrons around again. That's going to lead us to that sort of box-shaped intermediate that we've seen before. So forming a new bond here. And then this is going to look like my 6-membered ring, right? So here I've got my 6-membered ring. I'm seeing the same 6-membered ring here. And then just sort of finishing off that electron movement like we've done before. So now we're going to sort of regenerate our catalyst in a similar fashion as it was originally. So now we've got this methylene CH2 over here. And then our other product is going to be that product that I mentioned earlier, my cyclohexene. So this is really the ring closing product that we saw way back up here at the very beginning. And hopefully this mechanism makes sense. Like I said at the beginning of the video, the hardest part of this really is just keeping track of all your carbons, counting your carbons, making sure that you're drawing your pictures so they sort of make sense with the number of carbons you have. That's really the trickiest part, and it really does just take some practice, trial and error to figure out what the best way to do that is. So, all right, hopefully that helps.